Hello, everyone, and thank you for joining me today. My name is Wilhelm Hawker, and I manage the Enterprise Solutions Engineering team at Parasoft. A little about me my career in the software industry began 15 years ago, helping folks implement continuous quality and driving agile transformation and modernization, where none of it would be possible without the right testing strategy and quality metrics in place. So today, we're going to be sprinting through software development with quality metrics, starting with the whys, whats, then hows. I'll show you a live demo of how Parasoft enables its customers to identify potential quality, performance, or security issues using key metrics for each sprint and each release. Also, balancing quality and agility for testing priorities through test and code coverage and analysis. And lastly, creating measurable and achievable policies that govern your ability to achieve in sprint testing. So let's get started. And before we talk about software quality metrics, we should first talk about how software is developed today. It's common for teams to have a process that uses some form of iterative software development, like Scrum, and to use task planning software like those found in Jira, GitHub, or Azure DevOps. Right, so releases are planned by estimating the cost of user stories, weighing that against a team's capacity in each development iteration or sprint. Of course, feature development isn't the only thing that developers do. So, capacity is also set aside for other work like bug fixing, research, and infrastructure related tasks. So, here, these systems provide metrics and analytics with features like burn down charts and other tools so that when development managers coordinate with product managers, right, careful planning can take place. And really, product management wants to know what can the team realistically deliver in this release cycle that meets our business objectives, right? And the development team, they've estimated potential work items in the backlog with those story points. The release plan starts taking shape, and now everyone embarks on designing and coding against the plan. But as the saying goes, right, the best laid plans of mice and men often go awry. So let's look at some scenarios where things can go wrong. And first, I want us to consider the unexpected disruptions that directly impact a team's agility, right, or ability to deliver on the story points that they committed. And so, one unexpected task that's difficult to plan for is dealing with regressions, right? And a regression occurs when code is written that inadvertently breaks some other functionality that used to work. And when working on complex software, this is going to happen, right? And while it should be expected, right, expect the unexpected, as they say, it can have detrimental effects on a team's ability to deliver what they've committed to because they're getting distracted by addressing quality issues while they're trying to implement new functionality. And with shorter development iterations compressing the time window, higher levels of DevOps automation pushing velocity higher, the impact of frequent regressions gets amplified, right? And it can dramatically influence the predictability of your software releases, right? And predictability is really important when you're trying to run a business. So, to make matters worse, you can't really predict when a regression will be found, right? If you're lucky, it's shortly after the offending code was written, and so it's cheaper for the team to dive in and fix it. If you're unlucky, right, it could be weeks or months since anybody has looked at that code that's now failing, and this will have a larger impact on the team's ability to address the issue quickly. Of course, the worst case scenario, right, is your customers find the issue for you, and so the way you mitigate this risk of regressions is by shifting left the identification of defects earlier in the SDLC by one, leveraging earlier stage quality practices like deep code analysis and unit testing, which also has the effect of reducing the number of defects introduced in the first place by training the developers as they go. And two, with thorough testing that's done continuously. And we'll be breaking this down further as we walk down the road of software quality metrics. So, what are some other highly disruptive events that can impact a team's ability to deliver on their commitments? Well, let's remember what happened in November 2021 with Log4j. It's an extremely common logging library used by a majority of Java-based systems. And Log4Shell, as the vulnerability was named, this was described by security professionals as bordering on the apocalyptic, right? And we witnessed a massive disruption amongst many Java systems where companies, Parasoft included, scrambled to patch their software and provide guidance to customers for avoiding the vulnerability. And so, with such a high profile vulnerability, right, everyone acted quickly. And this extreme case highlights another risk to your software projects, which is the use of third party dependencies. And security vulnerabilities within these commonly used libraries are discovered all the time. And this can represent another risk to your business that development teams kind of have to be vigilant against. Now, depending on the purpose of your software, who the users are, and the criticality of it, tolerance of security risk can vary, but we know that security breaches are still prevalent. They're happening all the time. They certainly catch headlines. And that's not anything you want associated with your business. So, we'll also be discussing the role of security in software quality metrics today as well. So, what else? Well, we can turn to recent events with a major US airline that saw massive disruption to their crew management software and a resulting holiday meltdown. So the automated system, it buckled under the holiday spirit. And so they had to switch to manual crew scheduling, which is not a simple task given how complex flights, crews, regulations, and routing have become. And so this is an example of how a system's failure in scalability and resilience becomes another critical disruptor to the roadmap, right? I'm sure they weren't planning on dealing with this when they were looking at what they're working on in the future. So organizations will mitigate the risks of this nature um, with initiatives like shift left performance testing or chaos engineering, which will also have a place in today's discussion. All right, so we know testing is important, and while systems like Jira can help you gauge the velocity of the team, they don't necessarily help you gauge the quality of your work, right? And so, what development managers need is a source of truth born out of the quality process that helps them effectively manage their development iterations while factoring in quality, security, and performance risks, right? Not just speed. So, what metrics are important to track? Well, when considering this, it requires us to examine what kind of tests and analysis we're performing in our process. And to do that, I like to use the testing pyramid, which was popularized by Martin Fowler and the Agile community. And I like it because it offers a concise blueprint of how teams can build a scalable test automation strategy, right? Something that's not going to buckle under the pressures of agile or iterative software development. So at the base of the pyramid is your foundation of unit tests and API tests. These tests are much more efficient, so right, it makes sense to have more of them. They can be created earlier in the process, they're easier to automate and understand, and ultimately easier to diagnose the root causes of regressions and test failures, right? When we're thinking about shift left, right? This is one way of doing that. And then when we look at automated UI and manual tests, these tests need to be focused, right? Diagnosing failing end-to-end tests takes more work than diagnosing a unit test or API test. And these end-to-end tests often happen also late in the cycle, and their maintenance and overhead costs are high. So it's hard to scale and get sufficient test coverage when you're over reliant on the end to end test. Of course, these tests have a purpose, they're extremely valuable, but you have to be judicious with how many of them you're creating. And here underneath the pyramid, where you've shifted furthest to the left, and developers are writing code, we have code analysis, and this helps developers identify those security and reliability issues as they're coding and as part of continuous integration. And so this is really how organizations can follow this pyramid as a blueprint to help them create that test automation strategy that's scalable. So to kind of summarize some of the metrics that are important to track, starting with test results, um, when developers and testers collaborate as a cross-functional team or a unified team, right, that means looking at the total scope of their combined testing. And if tests are failing, you want your dashboard to tell you if the test failures are concentrated in a particular area, like unit tests or functional tests. And this is helpful for developers in that goal of diagnosing, right, what code changes in the build led to this regression, right? Where is the root cause of this issue? And the same is true for supported environments, right? Software is often built to support a variety of environments like different operating systems, database vendors, and browsers. And so if tests are failing in a particular environment configuration, that's also valuable insight for the development team to be able to narrow down the issue. And the trend continues, right? Especially if you're testing against a microservices architecture. End-to-end test failures, right? They're notoriously difficult to diagnose. And so that's why API testing with this kind of architecture specifically is so important. Are you seeing test failures with your front end, your orchestration, or back end layers? This is another useful division of your test results that helps developers pinpoint regressions that are detected with a build. Right? You want to have a variety of tests organized in logical ways, not just the end-to-end Selenium test and a bunch of those, and that's all you have. It slows down the process of remediation. So then here we have testing stages or the test environments. In the past, there may have been differences in these various stages, but now with Docker and Kubernetes, right, it may not be as much. Nevertheless, tracking your test results through test stages can also be insightful when developers are analyzing root causes. And so ultimately, these are a few common ways of looking at the test result data that I've seen. But that idea of splitting the results in ways that are helpful to the team is what you should strive for. And having a dashboard and reporting mechanism capable of doing that is going to be instrumental. Okay. Um, and across this variety of white box and black box testing also comes code coverage. And measuring code coverage from unit tests is pretty common, but getting that code coverage from your black box tests, right, your API tests, your UI tests, that's more difficult without a platform like ours that'll help make it easy. And you want to measure the code coverage across all of your testing methodologies, as well as merged code coverage so that your team has a deeper understanding of how their code is being tested, and more importantly, what code is not being tested. And so we know organizations will set high code coverage goals as a metric that's used to improve quality. And this is because every time developers change the code to fix bugs or introduce new features, they run the risk of introducing regressions. And for many teams working on brownfield development projects, high code coverage is a difficult or unattainable goal when they're trying to balance these business objectives. However, the same cannot be said for newly written or modified code that's within the scope of a sprint or a release. So, one way to stay agile without impacting quality is using these modified coverage analytics. And you want a platform that's going to allow you to essentially diff between a baseline build and a target build to calculate how much of the code that's changed has been covered by your tests. So, for example, the modified coverage for the sprint would be the code coverage of modified code between the latest build and the first build at the start of the sprint, right? And then you get the numbers from there. And this means that even if your overall code coverage doesn't meet your development policy, now the teams have an attainable goal in each development iteration tied to the code that they just wrote. And running these analytics throughout the sprint cycle can be helpful because teams will get real time feedback on whether their current regression suite is delivering sufficient coverage of the modified code, or if they need to invest in creating additional tests so they don't get uncomfortable questions during the sprint review. And so, speaking of the sprint review, if the team's modified coverage is low, uh, that means they're doing feature development at a pace that will cost them in software quality. Right? If we think back to that scale that we saw earlier, and we imagine it tipping too far in the direction of agility, using these analytics are a great way to kind of balance that agility and quality with data that's coming out of your process, right, out of your pipelines. So next, we have static analysis, which is an interesting technology. And as a pioneer of commercializing static analysis going back to the 90s, we've seen the practice go from niche to widespread adoption. Most teams I speak with today, they use one form of a linter or another, with that notion of enforcing style rules and other simple coding guidelines to streamline their code review process. But the technology can do more, particularly in the compliance arena, where a lot of our customers in regulated industries, they're required to prove compliance to secure coding standards like the OWASP Top 10, CWE, and PCI DSS. And so this is where commercial solutions like Parasoft provide SAST, or Static Application Security Testing, which has the deep and accurate code scanning combined with workflow and prioritization automation that's necessary to efficiently meet the standards compliance and ensure that the code is built reliably and securely. But here, just like exercise, it's an ongoing thing. And the static analysis metrics that you capture, these are essential in helping a team run that marathon of bringing their code into compliance with known standards and then staying in compliance once it's been achieved. And on the topic of security, we also kind of looked at the importance of checking your projects for vulnerable third party dependencies. And for this, there's a great open source software composition analysis tool maintained by the folks at OWASP called Dependency Check. I have the link right up there. This tool automatically updates itself with the US National Vulnerability Database hosted by NIST, and it lets you easily integrate its scans with your continuous integration builds. And this is an important metric for development managers to always be watching. When a new critical vulnerability is found in a dependency used by your software, that's an event that usually requires immediate action potentially with consequences that can impact the release plan. So this is information you want to know as soon as possible so that you can set expectations with your product management counterparts. And here, another security oriented testing practice that can be included with your DevOps pipeline is DAST, or Dynamic Application Security Testing. And so security professionals, they use specialized tools to attack your application interfaces for common security weaknesses like SQL injection, cross-site scripting, HTTP verb tampering, and others. So adding this kind of testing to the development and QA workload may seem like too heavy of a burden, but this is where platforms like Parasoft can make it easy for automated functional tests to be reused for DAST and easily added to the DevOps pipeline. So for low effort, security issues discoverable by DAST can be caught during development, and your security team will be happy because their certification process is going to be more streamlined, right? They're going to find less things late in the cycle that could interrupt or impact the release plan. And on the topic of performance, here you want to catch performance regressions early by automating performance validation as a part of your DevOps pipeline. And with automation comes measurement. And so flagging performance degradations through your automation infrastructure is also crucial to minimize that impact on the release plan or the customer experience. But this is another extra thing, right, that development and QA are being asked to do. But it's kind of another example of how platforms like ours enable organizations to shift left. Right here, functional tests again can be reused for automated load testing in your DevOps pipeline. And another part of what makes shifting left automated performance testing difficult is when you're trying to do it with end-to-end tests. Right? It's important to note that a robust process doesn't eliminate a performance team or security team for that matter. Right? Their roles are incredibly valuable. So consider that, with so many software architectures today becoming more distributed, right, containerized and cloud deployed, these trends are actually exposing opportunities that make it easier to componentize your testing, right? Focusing on the APIs exposed by your systems to be tested more granularly. And this is an opportunity because API tests happen to be great candidates for reuse when you consider functional, security, and performance testing. And so having a platform that supports this level of reuse is what allows Shift Left to work in practice, right? Instead of just in theory. And for challenges with the ability to run load tests in lower environments, here teams will turn to our service virtualization technology, where dependencies to tested interfaces can easily be simulated, thus kind of simplifying the requirements placed on the test environment and increasing the repeatability of testing. And so platforms like Parasoft can make this less painful than it has to be when comparing with open source alternatives. And from a metric standpoint, you want your software quality source of truth to baseline the performance of backend systems throughout the development process so that any changes in behavior, any degradations can be caught early, right? It's I think a common theme from today's session is how can we catch things early and how can we use metrics to drive an effective process? So with that, why don't we jump out of slides here and take a look. So I'm starting out by showing you one of our demo applications on GitHub called Parabank. This is a Java Spring application. And the reason I wanted to show you this first is to point out that we're actually going to be looking at two different builds of Parabank, one running against the master branch, and then another build that was run against Selenium demo. And so this Selenium demo branch, right, it's got several commits ahead of master. And so, right, the impact of these code changes is something that we want to explore. And so with that, I'd like to introduce you to Parasoft DTP. So this is our quality metrics, quality insights, analytics platform that kind of ties in, all the practices that we've been discussing so far. And so, our developers internally, our customers use DTP during the sprint review to help review the overall condition of a project and effectively balance that new feature development with quality, security, performance risks. And so DTP kind of complements the agile planning tools by including this information so you can make informed decisions. And so some things I'll mention here, right? I talked about the differences between baseline and target build. So here we can see I've got two builds in the system, B for baseline, U for updated. So if we compare these two builds, right, first build in the period versus target build, when our customers use DTP, they'll often change things when they're getting ready for the sprint review, like, okay, baseline build, first build of the sprint, right, target build, the latest build. And so with that, let's see what DTP has here. And I should mention these dashboards, they're all totally customizable. You can add widgets to look at different data. We have filters here that help you slice and dice the data that you're interested in seeing. So a lot of what I'm showing you here is kind of just an example, right? You can make this really your own based on what you care about looking at. So I'll start here with files changed. And so here we can see that, all right, we've got some tests that got added. Let's collapse the tests and just focus on source code, right? So if we look at the source code, we can see contact information, brand new class got added, and then pay.java. This got refactored to leverage this new contact information class. And then in the validator package, kind of similarly here, we've got some changes. And right, we can overlay static analysis violations here, which is quite nice. So when we're comparing between builds, right, we can see, did new violations get added or did existing ones get fixed? How many are left over? Right, from the perspective of changing classes. So, all right, we know what's changed between these two builds. So let's come back and let's first look at code coverage. That one is really interesting. I love looking at it. So here, notice that we have merged coverage across the different testing types that we're doing. We've got code coverage from unit testing, API testing, UI testing, manual testing. I'll come back to modified here in a moment. But if we kind of drill down into, say, our code coverage, and I want to actually look at the code coverage from the baseline build, right, the master branch. And so here, if we look and see, pay.java has a correlation to test cases that got run, right? So we're not just measuring code coverage kind of uncorrelated, but for each and every test case that you're running, we're capturing what code coverage is that test case contributing to the code base. And so I know pay.java has just this one test that contributes coverage to it. If we look at something else, we see additional test cases. And so this can be very useful when you're reviewing kind of what your tests are doing. Is it covering the code that you think it is? This correlation between tests and coverage also has another benefit, which I'll be exploring later around test execution optimization. All right, so a little about coverage there. Modified coverage I find extremely valuable, like we've been discussing in the slides. And so here, it's kind of interesting story. The existing regression suite is doing a decent job, except for this contact information, right? The new class that development added. We've got 4 lines of code that weren't covered here, right? And so when I'm looking maybe mid sprint and I'm seeing, oh, modified coverage is low in several classes, right? That's actionable information that you can, act on right away, right? And you can decide, okay, well, here we can see we have some test cases that are covering conditions in this equals method, excuse me, but we don't have coverage lower down. So, this might be a good example of a place where I would consider adding a unit test, right? And fully covering something core to the class like this equals method. And then if we look here to string, this didn't get covered, but it was changed, right? And so maybe this would be a good example for another unit test, or maybe this is something that your functional test should have covered, right? But useful information to dive in and make a decision about, how you should improve your testing, right? What changed code needs to be tested. Okay. So we talked about coverage a bit. Before I go on, I also wanted to mention that DTP here is an extensible system. We provide a REST API. So if you want to pull the data that we're collecting out of DTP and into another system, that's easily done through our API. And we also have our process intelligence engine here, Extension Designer. And so here you can build integrations between Parasoft and other systems, right? Automated workflows. You can build custom reports. So there's a lot of cool stuff you can do with the data that we're collecting um, in that service of, okay, how can we use this data effectively to manage our quality process and kind of the condition of our projects. Um, okay, so next up, why don't we look at test results a little bit? And so here I'm looking at Selenium tests. Here we've got bill pay showing up. And so depending on the type of test, we will show the source code of the test or a graphical representation if it's, let's say, an API test from Parasoft SoTest. And we can also show code coverage for that test case, right? So we saw it from the coverage view. Now from the test explorer view, we can also kind of surf code coverage for a given test, right? Say this test was failing, maybe I'd want to see what code this failing test was reaching or not reaching as I kind of diagnose why it's failing. Some other things that are useful, right? We have a test history. So, if a test has been failing for a while, right, that'll be evident in the history, right? If there's a flaky test, it passes sometimes, it fails sometimes, we haven't really locked it down to be stable, that'll be represented in the test history as well. So that's useful to see. And this prioritization view is also kind of very interesting. Here, since we're talking about metrics, I want to point out that our integrations with third-party planning tools like Jira or Azure DevOps and others, when a test result is reviewed, here we can have a task or a bug created in Jira in this case that links back to DTP. Um, and so, right, the team can add this to their sprint or their backlog. And this is a process that's helpful because tools like Jira are where you uncover how time was spent and on what. And so this workflow between our platform and the planning tool enables teams to gauge Well, how many defects are being discovered by our quality process, right? And not like false alarms, right? Not test failures that, oh, it was an environment issue or a data issue. No, a real defect, right? A real regression. And how many of those are we catching before we release to production, right? And maybe comparing that with how many production incidents you have. And so you want that link between, right, your quality system and your planning system so that you can start answering those kinds of questions and working on how to improve. And if your planning tool supports test case management, like Azure DevOps will have its test plans module. Since Jira doesn't support test case management out of the box, right? There's the popular X-Ray plugin for test case management in Jira. And so here we can also synchronize automated tests with the test case management system. And so this can save QA time by having a system that they're used to using and having it contain both the manual test results that they're running and automated test results all in one place, right? And requirements traceability with the testing process is a popular goal. So this can make it easy and streamline, getting that traceability between what you're working on and what you're testing, and including manual and automated. Okay. So the next thing I wanted to show you is another dashboard here that takes more of like a portfolio view across, right, several projects, several teams. Right, I mentioned that these dashboards in DTP can be highly customized to what you want them to tell you. And we get like portfolio test statistics or violation statistics where we're looking across, right, a spectrum of different filters is what we call them, right? So you can have filters for all the different kind of conditions that we looked at, right? How you can slice and dice data within a project or across multiple projects to see, okay, well, here, in this filter, we've got some test failures, right? In this one, we have more, right? If you have tests failing only in kind of one group of tests that you're running, right, that tells you something valuable. And then kind of similarly with static analysis violations, that's all there. Okay, next up. So let's scroll down a bit, and I've got some analytics widgets here that I think are pretty interesting to look at as well. And so with the static analysis process, we have AI and machine learning to help with prioritization. And the reason we built this is one of the biggest challenges that we've seen over the decades helping customers implement static analysis and adopt it effectively is, you turn on the scans and you just get flooded with findings. And so teams then have to kind of triage those findings and decide, right, is this something worth fixing or should we suppress it? And so, right, that can be kind of a long process. And this is where our machine learning algorithms can use build history, right, to determine, right, developer behaviors. What are they fixing and suppressing across the builds? And then predict what is the fix action of unreviewed findings, right? This would be here we've got 4,500 fix, 3,400 to review. All right, so we've almost cut the triaging process in half, so to speak, right? Focusing the team on more important items that they would decide to fix, and we've got a variety of other kind of analytics to optimize or make the workflow of static analysis efficient, right? Ultimately, this is a process that's helpful for the code, but right, we want our developers to spend as much time on feature development. So get in and get out as quickly as possible. Here, tests impacted by change is another interesting one. And so with this, we use code coverage and the change analytics of what code is changing to optimize which tests need to be rerun, right? And here we have it in report form But we also have this technology built into the CI/CD pipeline. So you can intelligently run just the right set of tests based on what code changed. And that's whether it's a unit test or an API test or a UI test. We have that built in to enable it. And then last thing I want to cover down here towards the bottom, I've got some widgets around compliance and security. So, we have a compliance framework that allows teams to kind of prove compliance in an efficient way and also produce PDF reports that are well suited for, say, an auditor. And in the compliance world, right, it's a little stricter, right? You can't kind of turn things on and off willy-nilly necessarily. You have to sort of, okay, if you're not going to fix a finding that's reported, then you need a good reason for it, right? And so deviations end up being something that we capture and document when we produce our reporting for compliance here. And while SAST is one type of security testing that can be done, DAST is another, right? So I spent a little time talking about how you should have a testing framework that makes it easy to reuse the tests you have for different purposes, right? You're building functional tests against your APIs and interfaces. Reuse those, right? Why reinvent the wheel multiple times to add additional overhead on the whole quality process? You should reuse the work you have and apply it in these different dimensions, right? Functional, performance, security, and then use that data to, right, collaborate with development. Right here, we have an HTTP verb tampering issue that was uncovered in the Parabank project. Right, risk and confidence here are presented, and if I drill down, I get a lot of great information coming from the tool that says, okay, we're using OWASP ZAP under the hood here, where we know which OWASP top 10 these are associated with, what CWE this is associated with, and more importantly, right, what is the solution to this particular finding, right? What are the references where I can read more about, right? So enabling the developers to act, right? Because security professionals, they're in short supply. Right, same thing with performance testing, in fact, right? This is a similar story. And so, right, they have the expertise, but developers are ultimately the ones that have to make the fix, right? And so, if we can enable the development team to act on the data that's coming out of the process, maybe with oversight, right, guidance and coaching from security and performance, right now you're effectively shifting left, right, and arming the development team with enough information that allows them to, okay, decide how the fix needs to apply for their project. Okay, so um, today we covered some really great information around mapping the aspects of your quality process to actionable data that's useful in balancing agility with quality, leveraging test results and code coverage to improve a team's ability to react to all the automation that they're running, create policies that fit an agile workflow, and allow teams to stay on top of quality, security, performance while working through their sprints and their releases. So, to request a personalized consultation on anything I've discussed today, just submit a request at our website, parasoft.com, where we also have other great resources like recorded webinars, case studies, blogs. And so I want to thank everyone for their time today. I hope you found this interesting and informative. And so let's kind of look at some questions that we've got here and see what the audience has to say. Okay, so first question here. How is code coverage calculated for a UI Selenium test? Great question. So Right, with unit testing, it's more straightforward, right? Unit testing frameworks will leverage tools like Jacoco or what have you to capture code coverage. But for functional testing, like Selenium tests, it's a little more involved. So, for example, say in Java, right? You're testing a Java application. And so there's a Java process running where we will deploy our Java coverage agent. And so when you're running your Selenium test, um, our Selenic product, which is part of our platform, it it will interact with the coverage agent that's running on your application and essentially say, okay, I'm starting bill pay test, right, to the coverage agent. So the coverage agent turns on, starts measuring, and then it tells the coverage agent, okay, I'm done with bill pay test. Now I'm starting create new account test, right? And so the coverage agent is receiving these events from the Selenium test execution that you have so that it can organize which code coverage was associated with each test case. And so ultimately that data is turned into a coverage report that's published to DTP where we saw it in the browser today. Is it possible to record this session for reference later? Absolutely. This BrightTalk webinar is being recorded. We'll have it available on our website soon. So stay tuned. You should be able to find it on the Parasoft website shortly. All right, it looks like we're a little over on time. We wanted to keep this at 45 minutes. So thank you all for your attendance. Thank you for your questions. Anything that we may have not answered right away, we'll get back to you. And with that, I hope you have a fantastic rest of your day.